All right, hello everyone. Thank you for joining today's webinar. This is a GeoGebra webinar on the newest GeoGebra resources that we released this school year. And we are coming on to the last webinar in this series on measurement. Today I have a special guest. I invited one of our instructional designers who actually worked on this project. She has made, out of the many hundreds of resources that are now GeoGebra created on the website, she has worked on a few hundred of them. And so I'm sure that she'll be able to give some really good insight into some of the design and some of the thought process that it went into making a lot of these resources, as well as just some insight into how you can use this in your classroom and some really good questions that you can ask, or how you can walk your students through this, and how to even walk through similar activities that you might be able to do in class. While she unmutes herself and introduces herself further, why don't you all participate in the chat? I'm going to ask you all to keep your microphones muted, but please tell all of us what you teach, where you teach, and even some of your social media handles. We'd love to just know. But yeah, please welcome Katie Sinclair.
Hi, thanks so much, Monique. I'm super excited to be with you guys here to talk about the measurement resources that we've been working on at GeoGebra. And yeah, as you guys are introducing yourself, please tell us everything. We'll tell you everything we know about these resources. And yes, I have been working on them at GeoGebra, as have you, Monique. So I'll definitely be tapping into your wealth of knowledge. Feel free to chime in and share information anytime you feel like it. Um, see, I'm coming to you from California, Rockland, California. Um, I used to be a math teacher. I've taught middle school and high school, and I have been in education technology for over a decade now. I have worked on creating educational games and interactive online textbooks and different types of online interactives, all mostly all math related. And yeah, this has just been a really enriching, exciting project. Working with Monique and the team, GeoGebra, we've really done some great stuff. So I can't wait to show you guys.
Mhm. Yeah. Um,
All right, so today we're going to talk about measurement, and we're going to do a live exploration at the end in GeoGebra Classroom. And while there are many more subtopics in the area of measurement, we're going to focus on area, perimeter, and circumference, units of measurement, volume, and surface area, and net.
um, So why don't we start off with looking at the GeoGebra homepage. For those of you who have been keeping up to date, this should be very familiar to you all, but for those of you who are coming into this new, or have used GeoGebra before but are not familiar with the resources, we can just point you to where you can find what we'll be showing you from the website. So this is the GeoGebra homepage, geogebra.org. And if you look right here, smack dab in the middle, there is a Start Calculator button, and there's also a Math Resources button. So the Math Resources button will direct you to our geogebra.org/math page. And if you have looked at this page recently, you'll realize that this is actually a revamped version of the page. Thanks to our website team, we have a nice modern and clean looking look and feel. And so this is just a recent update that's been happening, but we are going to be looking at the measurement subtopic for today, which is right here. And in the measurement subtopic, there are categories for upper elementary and middle school, or that's the categories in the States. But of course, these are all standalone activities like the rest of the resources on the GeoGebra website, and you can pick and choose however you like to use them. So Katie, was there one in particular you wanted to look at first?
So I think we're going to be starting in area. want to look at calculating area of composite figures using a quilt pattern. So really
So it'd be
fun.
under this subtopic, right? Area.
Yeah.
Um, yeah, and I think I pulled up a tab here, so we can just look directly here. So what am I looking at?
So I was inspired by the measurement involved in crafts like quilting and math making beautiful patterns. And so what we're going to do here is, Monique, can you click on the different patches that make up the quilt? And we'll be revealing
Oh,
different colors, purple, orange, and gray. And students can look at each of these patches as composite figures. So it may look like some funky little pentagon or hexagon or something, but it's actually composed of unit squares and triangles that represent half square units. And as you're clicking along, you can see the dashed lines indicating the different shapes that are composing each of those figures. And you can see a little tally that's there on the side in the chart where we're looking at the total area for each of the colors. And you can see them all listed. And then underneath that little quilt itself, you can see let's try tapping on one of the patches so you can see it happening. Yeah, there you go. So it tells you that that piece is composed of two triangles and five squares, and it actually calculates out that area right there in an equation. So students can see that, oh yes, this is 6 square units. And then that gets added into the table there as we continue to calculate the total area. And um, yeah, I just thought this was a pretty fun one. It looks nice. You get a nice little sense of completion after finishing it, and it could be a nice supplementary activity if you're doing something like a hands-on activity, like a student could design their own quilt, like a coloring page, or represent it using blocks to create composite figures, or even actual quilting. So lots of ways that this can be fit into other types of activities in the classroom. Um, yeah, and um, if you scroll down, so this is an exploration activity. And exploration activities usually have questions at the bottom. We call them putting it all together questions. These questions, as you can see, are all open-ended. And they're not so much calculation questions like um, calculate the area of this given composite figure. It's more how would you go about doing this? How does a quilter figure out how much of each cloth or each color is needed to sew their quilt? And get students thinking less about like the end result, the final answer, as about thinking about the process of the math itself. Um, so yeah, I really enjoyed this. It's fun to design.
yeah.
Yeah, let's
This is great.
try.
I like
Mhm.
how you mentioned that this is an activity that you can translate to some sort of real world application or some sort of hands-on activity. Like I can imagine even simply just taking out some graph paper and having students design their own quilt, having one sharing with their classmate and having their classmate calculate, yeah, how much fabric they would need theoretically. And then we can even start going into like scale figures and scale models. Yeah.
Yeah, and it brings the math back into the real world. You're not just looking at some abstract composite figure. It's like, oh, it's a quilt. We've all seen this before. Right. Let's look at another area one. So tomorrow, oh, it's gonna be the visualizing the area of a circle and its formula. Yeah.
I might
So
have
tomorrow is Pi Day. So we're gonna feature a few pie related activities here. Maybe you could use them tomorrow. And this one, we actually posted on social media, GeoGebra's social media accounts on Monday, and it got a lot of really good responses. So, all right, let's work through it. If you notice, we have the equation for the area of a circle, pi r squared. You can see pi is labeling the circle there on the side. and we can manipulate it. Monique, would you mind moving the slider to control the number of parts? And let's see, the one on the left. Yeah, you can vary the number of parts in the circle. Okay, bring it on back. And now we can animate the circle from a circle into a parallelogram. And we slide that one. Okay, nice. Okay, let's do it again, but a little slower. Yeah, we get this cool effect. So the circle unfolds, and as it's moving, oh, look, there's that number line where you see pi and 2 pi r, and it moves back over and creates a parallelogram that the pieces fits together, or what appears to be like a parallelogram. And once you go back over to the parallelogram, you'll even see the equation at the top for the area of a parallelogram. And hey, look at that. The area approximates pi r times r, coming from the base times height, which is a lot like area equals pi r squared. And from here, you could even manipulate the number of parts again within the parallelogram. And like I said, we posted this on social media on Monday, and one woman shared back that she created an actual physical manipulative version of this for her students to play with and examine the area of a circle. It was divided into a certain number of parts, and an activity like this could go along with it where you can vary the number of parts in there. You know, you can work with the hands-on activity, you can look at the picture in the book, you can work through the problems, but here you can vary variables like the number of triangles that partition the circle and the parallelogram. So if you scroll down, Monique, let's look at those questions again, that putting it all together. And again, these questions are not so much computational as they're asking students to make connections between parallelograms and circles, and really helping them to develop their thinking around the broader ideas of what's happening in the math, which is really fun.
Mm-hmm. Yeah, I see, like, for example, the students are given the equations and the formulas. And so the question is, how are the questions really point to how are they interpreting the formulas, or where did the formulas come from? So it's not just a memorization exercise.
Yeah, that's the one. Okay, so relating units within a measurement system. Okay, so let's take that little purple box, that number there, and just drag it horizontally and see what's happening. All right, so here, as if you notice, that number is changing. So what is happening as you go from box to box? Well, the phrases at the bottom are changing, the equation is changing, and we are actually converting between units in a given system. So we're looking at the number of centimeters in a meter, the number of, now we're looking at millimeters in a meter, and we've got the unit conversion equation happening there. And so students can take one given measurement and see how many different ways you could change it within one measurement system. But it doesn't just stop there. We also look at multiple systems of measurement. So if you use the drop-down menu, we can, yeah, now we're looking at feet. Okay, how many feet are in a mile? And we can look at the unit conversion that's happening, make that calculation, and then also look at the number of, in this case, yards in a foot. So you can go from the smaller unit of measure to the larger unit of measure and vice versa. And it's just a very succinct and efficient way to explore a whole lot of stuff. I think it's pretty neat. And we can even change the number if you press the new random number button. All right, voila, there you go. 6, a nice whole number. And then Move it around and vary it up. Right. Yes, that one's pretty fun.
This seems like a really
Um,
good activity to ask a lot of what do you notice and what do you wonder questions.
yes.
Because instead of just like we're here and because this is a webinar, we're explaining to you what some of these pieces do because we don't have a lot of time to spend on each one. But in a classroom setting, you might have your students just play around and then you ask them to find out, okay, what changes in between each of the boxes or what else changes on the screen, and then they all share and you can start a classroom discussion with that.
Yeah, and the questions at the bottom are all about explain it in your own words. All
Mhm.
right, so the next one, surface area and nets. We're going to look at that subtopic, calculating the surface area of cylinders using nets. I told you this Pi Day weeks, we're looking at more Pi stuff. And this is a really special interactive for me. So let's try spinning that little cylinder around. We get some of the cool famous GeoGebra 3D effects in there. All right, very nice. And then we'll press unfold to get a beautiful animation. And now let's just, yeah, we can increase the size. Thanks, Monique. We can click through each of the shapes and really look at what everything is. We've got circle, just pi r squared. We've got a rectangle, 2 pi r times h. Another circle. There we go, pi r squared. We add them all up, we get the surface area. You add up all those expressions, and there is your formula for finding the surface area of a circle using a net. But let's look at the actual, we've got dimensions in there, 2 for the radius and 2 for the height. So let's replace the variables. And again, we're going to go right back into that diagram and we're going to click on both of those 2's one by one to see how they fit into the formula. Yep, and those little boxes get replaced. And you can hit calculate and notice we've made the decision to have the system calculate out the answer for students. So in all of these applets, we're really thinking deeply about what is the key piece of learning here. And we write out specific learning objectives. And all of the thought around designing these applets are really getting students to think deeply and focus their learning, their mathematical thinking around a certain aspect. And when it comes to fulfilling an order of operations, that's maybe not the most important part of calculating the surface area. If a student is learning this for the first time, we really want them to make connections between what's happening with the net, what's happening with the formula, and how the dimensions fit in rather than, oh, I made a mistake because I accidentally multiplied a number wrong, you know? And so that's why um, there are some pieces where we're really making sure that students are thinking deeply about specific things using specific interactions, like interacting with the net, and then other aspects, we'll just take care of the calculation part for you. I mean, this is an exploration. That's one of the nice things about explorations is that, you know, we give a little bit of hand holding to allow students to really wrap their minds around a new idea. And this applet was one that I worked on early on when I was working on this project at GeoGebra, and it was a real big task to try to figure out how to fit all this into the little frame of a GeoGebra resource. But I just had this wonderful experience of going back and forth with the author who created it and our UX reviewer, and we just were collaborating and brainstorming and came up with this, which I'm really proud of. And in fact, we ended up using this as a template for lots and lots of other interactives. So if you scroll down, Monique, you'll see that we have more, lots more related activities. And this is only just like a little subsection of some of the related activities. We've got nice thumbnails there, and you can see how a lot of these, we've got the nets and we've got the formula, replacing the variables, like they're all kind of in the same vein. And you could get a nice little sneak peek without having to open up the applet and see what this is all about. Um, And yeah, so some of them are, that looks familiar, the quilt, a prerequisite resource. We've got more that are in the same category, and then even ones, if you want to build off of this and you want to keep going, there's next resources. Oh, hey, that one looks familiar. The one on the left there, I'm actually going to be posting to GeoGebra social media tomorrow. So stay tuned. All right. Oh, I know we're crunching it on time, so I'll try to be quick. Okay, so we've looked at a bunch of exploration resources, but we also have practice resources. So let's look at what those are like. Practice resources are more assessment oriented. There are actual correct answers. The students have to try to answer correctly. They get multiple attempts. We give hints, we give information in the solutions. So this is a really fun one. Okay, can we try putting, first let's try doing this one correctly with an expression. So Monique, do you mind writing in 17 times 2 plus 10 times 2? And just see what it looks like when it's correct. Yep. And if you notice, we accept, a lot of the times we accept answers in different forms. So if the student is showing they understand this so well that they could write it as a full expression, all right, you got it. You understand this word. It may not be the simplified answer, but you're showing that you have knowledge about calculating perimeter. Yeah, so I see you're hovering over the button. Go for it. So we're looking at a couple different ways to represent the solution here. One is by using the formula, the dimensions just fly right in. And then the other is using the model. So students can actually see this nice animation of what the perimeter is. The point is going all the way around. It's building the fence around the garden. And if you notice, yeah, as it's moving along, each of the dimensions are popping in and creating the formula, the length plus the width plus the length plus the width, and you get the simplified answer of 54 feet. And yeah, so let's move on to the units measurement one, estimating liquid volumes. And oh, I'm seeing a question. Should you show how one of these resources was built? We would love to do that. That's a whole other topic. Yes, thank you for that question. That would be a whole nother webinar in itself. So this one we posted recently on social media and it got a lot of positive feedback. One user said that this would be really cool for visualizing geometry and physics principles. So let's see what happens here. Let's try answering this one incorrectly, if you don't mind me, just a random digit. And okay, so a lot of these applets, the coolest stuff is built into the hints and solutions. So you wouldn't see this if you just got it correct. But let's move the one on the left, the slider on the left, and see. Okay, now we can vary the height. And let's try the slider on the right. And we can vary the height as well there too. We have some guiding questions built into the hint and some suggestions about what they can do. All right, let's try answering incorrectly again. Let's see what happens next. Okay, we've got a little more information telling us that each measuring unit marks 200 milliliters. Okay, so that's helpful, but let's say we just get completely wrong and we missed all our attempts. Nice. All right, so there's the answer. Great. We could see a beautiful visual. We've got the solution written out, but there's the animation. And this is the really cool part. You can't do this in the real world. Slices of water moving one at a time. So you could see piece by piece, very quickly, very succinctly, what's happening here, how you can estimate the amount of water on the right based on the given amount on the left. And um, that's why this applet has been getting so much positive attention online once we shared it. Um, yeah, really cool, very pretty, and uh, an example of how GeoGebra can just take things to the next level. Right. Let's see. Let's try to fit in one more circumference one. If you don't mind, the calculating circumference of a circle. And hey, Monique, uh, this one, let's see. Ooh, actually, ooh, no, that one we can use for GeoGebra Classroom. Maybe we can skip past that one real quick to the um, the invisible cubes one. Yes, 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 that's the one. All right, so Monique is actually the designer on this one. So would you like to take it away and tell us what this one's all about?
Yeah, sure thing. This one was a fun one. I got inspired by this because I saw a worksheet that had only a handful of problems that use this, and this is really an elementary level concept, which is understanding volume in 3D space and how, you have to, when you're considering volume, you consider space that you don't always see just from a certain viewpoint. And so this is a 3D shape, but you aren't allowed to view it from different angles because you have to understand that there is more to the shape than just what you see right here on this 2D screen. Um, but we're supposed to calculate the volume. And we're not explicitly given all of the line markings that show us how each of the faces are broken up into smaller squares, and how we can break this shape up into cubic units. But we have to be able to imagine and understand that visualization. And so the input box, it uses the same GeoGebra engine to calculate equivalent expressions. And so I might, yeah, I could enter, this as an expression three times, if I understand the multiplication formula, three times one, two, three, four, five times, this is a square. So maybe three times three times five, three times three times five, and then it'll show up. But I could also get a different number. And if I don't quite know what to do, I can have the dynamic system show me some of those lines as scaffolding. So on this problem, at least I can see, okay, there are one, two, three, four layers of a 3 by 3 um, set of blocks. So it's 9 times one, two, four. And then on the next problem, I get thrown right back into, okay, now it's just tick marks again. You saw how those lines were drawn. Now try and apply it again here. And so it's low stakes, helping to, yeah, just practice what is what they've learned in previous examples. Um, yeah.
Yeah, that one's so great. Looks really nice too. Um, all right. So, do we want to take a look back at the slides? Because I collected a whole bunch of pi day measurement resources for you guys. So in addition to the other ones we went through, here's a handful more. And if you want access to these slides to click through the links and grab all of these for tomorrow, here's the QR code. So please use this. It's all for you. It's all free. We hope that you can use this in your class tomorrow and celebrate Pi Day with your students. Have a lot of fun. Um,
So that is, I'll leave this QR code on for just a couple more seconds in case you need time. But I will also, again, like this recording, we'll stitch it together and we'll have it up on our YouTube channel in a bit. But I'll let you get the QR code where it'll take you to a form and you just type in some information. It'll redirect you to a copy of the slides. And then you'll be able to see all those links in case you need them for tomorrow, or it might even be today for some of you, depending on where you're tuning in from. Um, Yeah, we don't really have time for questions. We can stop the recording and then address some questions afterwards. But yeah, here are some information about Katie, her socials. She is the instructional designer and has been doing great helping us with social media recently. Um, and yeah, if you have any other questions or feedback or suggestion about what you've seen today or some of the resources, feel free to email community@geogebra.org and then follow us on socials. So again, just wanting to point out that this will be uploaded to YouTube. So if you are subscribed to our YouTube channel, you should be able to see when the recording becomes live.